Now let's do the second half of this. My friend Bob collects a sample and his p-hat is 90 out of 200, which is the same decimal, 0.45, as we had earlier with 18 out of 40. Now calculate the standard deviation of the normal distribution. Again, why is it okay to use the normal approximation? We have 90 successes and I believe 110 failures, but double check me on that, for a total of 200 observations in our data set. So that's well above the threshold of at least 10 of each. All right, so let's do our calculation. Now it's similar to the one we did previously, only this time, so we're still assuming in our null hypothesis that pi is 0.35. But this time our sample size, n, is 200. So again, if I were you, I would pause the video here, put this in your own calculator and make sure you can get the correct answer, and you should get 0.034. So for this normal distribution, if I were in the applet and I could click on the summary stats, the mean is still going to be 0.35 because that's the value I assumed in the null hypothesis. But now notice the standard deviation is quite a bit less. It's less than half as much as it was before when I have this larger sample size. So right in the middle of the distribution is the 0.35, and then to fill in the grid marks to the right of that, I'm going to add 0.034, and I get 0.384. Again, this is a little bit squished. If I take my 0.384 and I add 0.034, another standard deviation, I get 0.418. And if I take the 0.418 and add another standard deviation, 0.034, I get 0.453. So again, make sure that you are following along using your own calculator. Make sure you can get these same answers. Then if I go back to the center at 0.35 and I subtract 0.034, I get 0.315. And if I'm at 0.315 and I subtract 0.034, I get 0.28. And if I'm at 0.28 and I subtract I think that's 0.281, and I subtract 0.034, I get 0.246. Again, you can, or 247, just double check my math on that. Okay, and once again, we want to place the statistic of 0.45 in this picture. Well, now that's way up by the third grid mark, the third standard deviation above the center. So it's definitely in the tail compared to in the previous picture. The 0.45 was not in the tail, it was closer to the center. But now, because our standard deviation has gone down with a larger sample size, that same p-hat of 0.45 is now further in the tail. Now, if we calculate the standardized statistic, once again, we're going to take our statistic minus the mean of the null distribution from what we assumed in the null hypothesis, divided by the standard deviation, and this time we get 2.94. So this makes sense with where we put the red 0.45 in that picture. It's almost 3 standard deviations above the center of the null distribution. It is almost to the third grid mark above center. That's what that means. And the strength of evidence against the null hypothesis is, well, it's technically strong, but it's almost very strong. If we had made it to 3 standard deviations, we would have very strong evidence against the null hypothesis. So just a reminder, okay, and let's interpret this 2.94. The statistic p-hat equals 0.45 is almost 3 standard deviations above the center of the null distribution. Okay, so we have the same statistic, but it's in a very different place in that null distribution. That's all depending on the standard deviation, which itself depends on the sample size.